Now that we've learned to test whether a function can have an inverse, we are going to start writing inverse functions. In inverse functions, the domain becomes the range, and the range becomes the domain. Now, what does that mean in terms of problem 18? This means that y's become x's and x's become y's. The values of each point are flip-flopped. So we are going to begin problem 18 by verifying that this is a one-to-one function. Do we have any repeated y values? We do not. Therefore, it is one-to-one. Now, we're going to determine the domain and range of the inverse function. So the domain of the inverse function is going to be the y values of the original function. I'm going to write this as a set, curly brackets. The range is the x values of the original function, 0, 1, 2, and 3. Now let's write the inverse function. So the inverse function is written as f to the negative 1 of x. That's what it looks like. We're going to write this in set notation. So we're going to use curly brackets, and we're just going to flip-flop each one of these points. Seven, 2, and 9, 3. So when you are looking at a set of points and trying to determine their inverse, you just flip-flop those points around.